Hey there, world. Welcome back to the lab. Today, we are entering the world of 3D printing for robotics and engineering. If you have ever wanted to turn your ideas into real, functional parts, you're in the right place. From precision gears and sensor mounts to custom joints, actuators, and even full 3D printed robot heads that talk, 3D printing opens up endless possibilities for engineers, makers, and innovators. In this series, we're going beyond just pressing print. We will dive into everything you need to take your designs from concept to reality. We will start with slicer settings, understanding how infill, layer height, and orientation affect strength and performance. Then we will cover printer calibration, so your parts come out dimensionally accurate every time. We will even capture stunning time-lapse videos so you can share your prints like a pro. And finally, we'll explore 3D modeling for engineering applications, teaching you how to design parts that don't just look good, but actually work. Whether you're just getting started or you want to sharpen your engineering design skills, this series will give you the tools and knowledge to bring your robotics projects to life. So hit that subscribe button and let's start printing the future, one layer at a time. Let's get started by digging into the software side of 3D printing. I'm talking about slicing software. A slicer prepares digital 3D models for 3D printing by slicing them into horizontal layers that can be printed. There's lots of different types of slicers out there, but we're going to use Ultimaker Cura, one of the most popular slicers out there. Cura is open source, which means it's free to download and use, and we can modify the software anytime we would like. Under the hood, a slicer is quite complex. Luckily, Cura balances complexity with ease of use for beginners, while still providing expert users with over 500 parameters that can be controlled. But that's not the only reason Cura is so popular. The algorithms behind the slicer are well maintained and elegant, leading to more efficient slicing and better looking prints. Cura also has regular update cycles to usher in new features and fix bugs. Where exactly does the slicer fit into the 3D printing process? You can think of 3D printing as having 4 steps. Step 1. Download or design a 3D model. There are plenty of free sites out there to search for and download 3D models for printing. Thingiverse, Printables, and Things are 3 pretty common ones. Or you can design your own model using CAD software. We will actually go over designing 3D models for robotics using Fusion 360 later in the video series. Step 2. Import the 3D model into the slicer and prepare it for 3D printing. Most 3D models come in 2 formats, STL and 3MF. When a model is designed in CAD software, it is comprised of sketches, primitives, and splines, and it is relatively easy to modify and change as you desire. An STL and 3MF file only contains the geometry of the model, making it extremely difficult to modify either of these file types. 3MF files can also contain texture and color information about the model. In this series, we'll be working with STL files. Once you import the model into the slicer, you can position the model, scale it, and rotate it prior to slicing. How your model gets sliced is dependent on the settings you configure within the slicer, such as layer height, infill density, support, and bed adhesion. The slicer will create a G-code file based on the model dimensions and the slicer parameters defined by you. Step 3. Export the G-code. When the slicer splits the model into horizontal layers, it generates instructions your 3D printer understands, called G-code. Without slicing software, your printer would have no idea what to do with your design. G-code is also used for other computer-aided manufacturing tools, like CNC machines. We can save the G-code to an SD card and upload it to a printer, or we can drag and drop the file if we have a networked printer. And step 4. Print the model. Select the G-code file for your model and hit that print button. Let's quickly talk about G-code. If you are new to 3D printing, it's not super important to have in-depth knowledge about G-code because Cura takes care of it for you. However, we will be using some G-code commands later in the series to calibrate our 3D printers. And as you learn more about 3D printing, you may want to edit some of your G-code manually to fine-tune some settings or troubleshoot a problem. Luckily, G-code is relatively easy to understand because the commands are straightforward and it's executed line by line. We'll have a video later in the series dedicated to understanding G-code. But enough about that. Let's get to the real work. You'll need to download Cura if you haven't already. I've included the link down below. Cura is available for Windows, Mac, and Linux. Pause the video if you need to and go download Cura for your operating system and get it installed. I'm using Cura 5.10.1, so your workspace might look slightly different if you're on a different version. That's okay, because there haven't been any drastic changes to the workspace. Once you have Cura installed, go ahead and open it up. Along the top of your screen, you should see tabs for Prepare, Preview, and Monitor. Just below the tabs, there are 3 columns. The one on the left is for your printer settings, the one in the middle is for your filament, and the one on the right is for your slicer settings. Let's set up a printer. I'm going to click in the printer settings column and add printer. You can also select settings from the menu bar, then select printer and add printer. If you have an Ultimaker printer, select that box. If not, select the other box. Now I'm assuming that most of you have a non-network printer, so click in that box. Now you can search for your model of printer. If Cura doesn't list your model, you can create a custom printer. Creating a custom printer requires a bit more work because you will have to manually enter all of the printer settings. Use your printer manual and the website to ensure you enter the correct dimensions. If your model is listed, select the radio button next to your printer and then click the Add button. Now we can move over to the filament column. You will notice that there are lots of options available for the various brands of filament and the various types of filament. If the brand and type of filament you use is an option, go ahead and select it. The generic brand works pretty well if you're printing with PLA, PETG, ABS, and TPU. You also have the option to fine-tune these settings with your actual filament, but we'll go more in depth on that when we calibrate our printers later in the series. For now, either select your filament brand and type or use the generic version. For this video series, we will only print with PLA, but we'll have a video discussing the types of filament, why you choose to print with that material, and some of the complexities associated with each of them. Okay, now let's import a 3D model to play around with. Let's print something small and simple. You can find the link below to a 3D model that's found on Thingiverse. It's an owl, designed by Cura. This is a good first print to see how the slicer and printer perform. We can then tweak some of the slicer settings and try it again after calibrating our printer to see if we did any better. Once you download the file, you can open it up by either clicking on the folder icon to the left or by clicking on File, Open File from the menu bar. Your model shows up inside a 3D box, and this box matches the build size of your printer. I'm using the Anycubic Cobra Max printer, which has a build size of 400 by 400 millimeters by 450 millimeters. It's okay if your box doesn't look exactly like mine, unless you're using the same printer. You can now pan, zoom, and orbit around your model. Go ahead and click on your model. And now you can use the tools on the left side of your screen. You can move the model around on your build plate. This is useful if you're printing multiple models at the same time. You can scale your model. I'm actually going to scale mine to 60%. One, this will reduce the print time, and two, it will reduce the amount of filament required. Notice the uniform scaling box is checked. If it was not checked, you could enter different scaling factors for each dimension, which could really throw off the look of your model. You can also rotate your image. Mirror your image. Modify the way your model prints. You can block certain support structures. And you can measure your model. Click on the Preview tab, and you'll notice that your model is grayed out. This is because it hasn't been sliced yet. Go ahead and click the Slice button in the bottom right. Now you can see your model in the preview plane. Along the bottom of the screen is a play button. This allows you to watch a simulation of your print. Along the right side is a layer slider. You can adjust this from your first layer all the way up to your final layer so you can see what your print settings will look like. Notice the center column now shows color scheme for your preview. The default is line type, so you can tell what's considered infill, outer walls, inner walls, and where the start point of each layer is. You can also look at the preview based on print speeds. Notice how the exterior of the print is much slower than the infill. This saves time in printing while minimizing observable flaws in the print from the outside. You can also look at the flow rate. But for now, go ahead and set it back to line type. Now let's dig into the slicer settings. Whenever you make changes to any setting after you have sliced your model, you'll be required to go back and slice the model again so the updated settings can be applied. Click the settings box and it will show you the recommended settings for the filament you are using. Click the Show Custom box. This allows us to see all of the various parameters that we can adjust. We're not going to hit all of them in this video, but we'll cover some of the more important ones. Let's start with layer height. 0.2 is a normal value if you're using a 0.4 millimeter nozzle, which most printers use. You never want to go larger than your nozzle size, and 0.06 millimeters is probably the smallest. 0.2 and 0.15 millimeters are generally the settings I use the most. Notice that all of the line widths are set to 0.4 millimeters, which again is the size of the nozzle. The initial layer line width is set to 140%. This helps with adhesion to the bed. However, if you are seeing your first layer noticeably bulge out, you may want to reduce this setting. I keep it because I do not print with a brim, and I haven't noticed any issues with my first layer dimensions. Moving on to walls, you can set your wall thickness. This is important for components that have holes for screws or are load bearing. You may need a thicker wall depending on the situation. It's also important to keep your walls thick enough that you don't sand through them when post-processing your prints. For our owl model, we'll keep it set at the default setting of 1.2 millimeters. Next, let's talk about the wall ordering. By default, the inner walls are printed before the outer walls. This is best if you are printing overhangs without support. However, for most of our robotics and engineering projects, we are more concerned with dimensional accuracy. Printing the outer walls first helps us achieve better results, so we will always print outside first unless a certain component requires us to change this setting. Keep scrolling down and let's talk about horizontal expansion and whole horizontal expansion. Horizontal expansion assists with the pieces that need to fit together. Positive values compensate for spaces that are too big, and negative values compensate for spaces that are too tight. For our print today, we will keep it at the default value of 0, but we will play around with this setting when we calibrate our printer in a later video. I do not recommend using the whole horizontal expansion unless absolutely required. This setting is difficult to dial in and can have adverse effects if you have holes of varying sizes within a single model. If any of my holes are too small, I use a hand drill to drill them out to the correct size. Top and bottom thickness. Notice these are set to the same as our wall thickness set earlier. Keep in mind, if you change your wall thickness, you'll want your top and bottom layers to match. Now let's go down to our infill density. The default value is 15%. This means that the inside of our model will be filled with 15% support structure. This may not seem like a lot, but for decorative purposes, this will suffice. In terms of structural performance and load bearing, you may need to go up to 30 or 50% depending on the requirements. Anything more than about 60% is usually just wasting filament, and there's not a lot of value with any infill density higher than that, with an exception or two. Next, we have our infill pattern. There are a lot of options here. We're going to keep the default setting, but each pattern has its own set of strengths and weaknesses. Lines provides the least amount of strength, but it uses less filament and prints really fast. Grid has an excellent strength to weight ratio, but takes longer to print and consumes more filament. Gyroid is great for if you want to fill your print with something to strengthen it, like epoxy or concrete. It is great because it prevents bulkheads from being formed inside your print, which would prevent any type of filler from getting into all the spaces inside. Triangles provides good strength anytime you have high lateral loads acting on your component. The cubic and trihexagon are good for mechanical use because of their excellent internal support and near isotropic mechanical properties. That's just a fancy way of saying that its strength and its stiffness are nearly the same in every direction. Now let's go down to printing temperature. Make sure this is set to 200 degrees Celsius for PLA, and also set your initial layer printing temperature to 200 degrees. We will also set the initial printing temperature and the final printing temperature to 195 degrees. We will test out different temperature settings when we calibrate the printer by printing a temperature tower model. If you have a heated bed, set it to 60 degrees for PLA. We're not going to discuss print speeds today, but printing speed can have a major impact on the quality of your prints. We will discuss printing speeds later in the series. For now, go ahead and scroll down to support. Generate support should be unchecked. There will be very few times we print with support. The last setting we will discuss is the build plate adhesion. The default value is brim, which prints a circular base on the outside of your model to help it adhere to the build plate. I have found that most of the time a brim is just difficult to remove and can cause impurities with the initial layer that prints. I like to use the skirt. This allows the printer to prime the extruder before printing the initial layer. I also make the skirt 15 millimeters from the distance to the model. So if I need to wipe some excess filament off the build plate, I have room to work with. I also set a minimum length to 250 millimeters, so it gives that good amount of priming the extruder before my initial layer prints. Okay, that's it on the slicer settings for now. Go ahead and slice your model and either save the G-code file to your computer or save it to an SD card for your printer. Don't worry if your model doesn't come out perfect. There are so many settings we can tweak within the slicer, and we still need to calibrate our printers in the next video. Save your print when you're done though, so you can compare it to the next one you print after calibration. And that's it. You just learned how to go from 3D model to G-code to printed object, all with Ultimaker Cura. With practice, you'll be customizing settings like a pro. If there is a burning question in your mind about slicers or 3D printing, drop it in the comments. I will do my best to answer it or create a video about it. Don't forget to like and subscribe, because coming up, we're going to walk through calibrating a 3D printer to get the best prints possible. Until next time, keep creating and happy printing.